video is about completing the square, which is another method for solving quadratic equations if you don't want to factor or can't factor. So completing the square for a quadratic expression means to fill in the correct c value to create a perfect square trinomial. So trinomial means we've got three terms, and you're used to seeing this like x squared plus 8x plus some number. You can choose that number c to complete a perfect square, which would be so that when you factor it, you get the same thing twice. So in order to figure out what c should be in this first example, so that we can factor this to get the same thing twice, it's going to be half of this number here, which is called b, so half of b, and then raise that value to the second power, and that'll tell you what your c should equal. So when you're calculating c for perfect squares, you want to do half of b and then square it. So for example, half of 8 is 4, and 4 to the second power is 16. So when we complete this perfect square trinomial, it'll say x squared plus 8x plus 16. In order to check that it's right, I'm just going to show you here. If I tried to factor this, I would split up the x squared into x and x. I'd be looking for something that multiplies to make 16 that adds up to 8. And what multiplies to make 16 that adds up to 8 is positive 4 and positive 4, which can be written as x plus 4 to the second power because it is the same binomial twice. So when you have the same binomial twice, you want to write it with that exponent too, and we're going to use that in the further examples here to actually solve these. So let's practice doing it when it's an odd number. Half of b. If b is an odd number and you have to divide it by 2, please leave it as a fraction. It's just a little nicer to see. And then raise that to the second power, and that's going to be what our c value equals. So in this case, when you raise a fraction to the second power, negative 7 times negative 7 is positive 49. 2 times 2 is 4. So you're going to square the top and square the bottom. And then rewrite this as x squared minus 7x plus 49 over 4. Not very pretty, but it's correct. So we're going to apply this in equations to solve them. For example, x squared minus 10x plus 1 equals 0. If I told you to solve this, you're not going to be able to factor it, no matter how hard you try, because you're going to look at that positive 1 and think, nothing makes positive 1 that adds up to negative 10. You won't be able to find anything, and therefore you can't factor it. That doesn't mean you get to just quit. You can now use completing the square method. So let's do one of these by completing the square. The first step in completing the square is to get your two x variables here on the left and move anything else to the other side of the equation, which is not what we do when we're factoring. When we're factoring, we want it to say equals 0. If we can't factor, we want to keep our x's together and move anything else to the other side. Then we're going to insert our own c value. We don't like their c value, which was a plus 1. We couldn't do anything with it. So we're going to insert our own c value. And just remember that anything you do on the left side of the equation, you have to do on the right side of the equation to keep it balanced. So we're not breaking any of the rules of algebra here. Find that c value doing what we just did on the first slide by taking half of the middle value, which is b, and then squaring it. So half of negative 10 is negative 5. And negative 5 to the second power is 25. Remember to add it to the other side as well to keep this thing balanced. We're going to factor what we just got into two parentheses, and you should always, always get the same thing twice if you chose that last number correctly. So what multiplies to make 25 that adds up to negative 10 will be minus 5 and minus 5, which we're going to rewrite as x minus 5 to the second power. And then we're going to simplify what we had over here, which is just, oops, did that wrong. Negative 1 plus 25 is actually 24. Okay. When you have an equation like this, we can solve using square roots, which is the very first type of solving method. You could solve this using a square root just to cancel out that second power, as long as you remember to put a plus or minus so you get your two answers. So x minus 5 is what we have left over here. Plus or minus the square root of 24. Remember to simplify this. We're going to break it into root 4, root 6, which is 2 on the outside and root 6 on the inside. And then add 5 to the other side, so x will equal 5 plus or minus 2 root 6, which is not an answer you ever would have been able to get using factoring, so that's why we had to use completing the square here to get this answer. Let's try it again here. It already has the 13 on the other side of the equal sign, and that's good. Remember, when you're completing the square, you don't want it to say equals 0. You want it to have everything on the left that has x in it, and anything else should be on the right side of the equation. Let's stick in our own C value, because the 13 doesn't help us at all. We find C by doing half of B to the second power. And negative 6 divided by 2 is negative 3. Negative 3 squared is positive 9. Do the same thing on the right side of the equation. Factor what you have on the left, which should always end up being the same thing twice. Add together what you have on the right. Rewrite this with an exponent on it so that you can use square roots to solve this. So we'll square root this, remembering to put a plus or minus in front. X minus 3 equals plus or minus the square root of 22, which can't be simplified. And x equals 3 plus or minus the square root of 22. In a case like this, don't do more work than you need to. If you recognize right away that what's on the left is already a perfect square trinomial, then just factor it right away. You've already got plus 16, which is the correct C value for factoring this as x minus 4, x minus 4. Just wanted to demonstrate this in case you come across any that are already a perfect square. You recognize it, you can use this method without filling in your own C value. We don't have to add anything to the other side because we're not changing the left side of the cell. We can square root both sides, just remember to put a plus or minus in front. X minus 4 will equal positive and negative 5. I'm going to write this as two separate equations so I don't forget one of my answers. When you add 4 to this, x equals 9. When you add 4 to this, x equals negative 1. One special thing about completing the square is that you must have a 1 in front, so a coefficient of 1 in order to use this method. If I give you a trinomial like this one, there is a 3 in front. You want to see if you can divide everything by 3 first. And if it's possible to divide everything by 3 evenly, then you can go ahead and use completing the square. So let's divide everything here by 3. I can do this to both sides because it says equals 0. And on the left, I'm left with x squared. 36 divided by 3 is 12. 150 divided by 3 is 50. 0 divided by 3 is just 0. I'm not going to be able to factor this because nothing makes positive 50 that adds up to negative 12. So I'm going to use completing the square, which remember means you want to keep your x's together, and you want to move anything else to the other side. And then you want to insert your own C value, adding it to both sides of the equation to keep it balanced. Our C value is going to be half of negative 12, which is negative 6, to the second power, which is 36, as long as you add that 36 to the right side of the equation as well. Factor this as x minus 6, x minus 6. Add these two numbers together to get us negative 14. X minus 6 to the second power equals negative 14. Always be on the lookout for this in case I give you one of these. When you do the square root of a negative number, don't try to simplify it. Don't take out a calculator and do it. Immediately recognize that square roots of negatives are imaginary. They're unreal answers. And so you can write that this is a non-real solution or no real solution. If you have a case like this where there is a number in front and you can't divide everything by 3 without getting ugly decimals, then it might be easier to use the quadratic formula, which is the final method that we're going to learn for solving these. But we're going to do that one in class or on another video. So just be prepared to come across an example like this and not use this method because it's going to create too much work. And that is all.